Hello viewers, today we'll discuss about the types of functions. Before we discuss the types or classify the function, first you observe these diagrams. Here we have taken two sets. First one is x1, second one is x2. This is our domain and this is our codomain. The domain consists of elements x, y, z and here a, b, c, d. So we are defining a function here f1, and under this function we observe that every element of the domain have a correspondence with the elements of codomain, and distinct elements, here the distinct elements of domain have the distinct images. These are the images. And the second case, under f2, we have seen that two elements we found in x and y which have the same image b. And further, we see also that A and D, these are two elements of the codomain which have no pre-image. So under this we are saying that not images of any element. A and D are not images of any element of x1. And under F3, we have seen that x and y have the same image A, and the z has image B. And further we have seen there is no extra element in the codomain which has no pre-image. So if we are writing under F, x and y have same image in x3, and all elements of x3 are images of some element of x1. And the last one, under the function f4, we have seen here the images of distinct elements are distinct all the elements of x4, and all the elements of x4 are images of some element of x1. So on the basis of the observation, we are classifying the types of function. First one is defined as 1, 1. See in the f1 and f4, there all elements of x1 have distinct images in x2. So this is 1, 1. So if we take x1, x2 belongs to domain such that fx1 is equals to fx2 implies that x1 is equals to x2, or fx1 not equal to fx2 implies x1 not equal to x2, then f is said to be 1, 1 mapping or 1, 1 function. So 1, 1 or another term we use, injective. In case of F4 also we observe same thing, that distinct elements of the domain have distinct images. But the difference here the all elements are not that is codomain have some extra element which is there is D, which has no image, pre-image in the domain. But here all images are elements have a correspondence with the elements of the domain. Another thing, if a function is not 1, 1, not 1 1, then it is called many 1. Many to 1 function. So you can see that F2 and F3. F2 and F3 are many to 1 function. Their mappings looks like this form. Two elements x and y mapped on the same element. Now another important function is onto or surjective mapping. Here we defined onto function that a function f from x1 to x3 is said to be onto if every element of x3, that is every element of the codomain, is the image of some element of x1, and there is no extra element here which has no correspondence with the elements of the domain. So for every x1 and x2, there exists an element x1 of, and here you can see that this is the range. We have learned this is the range, and here range and codomain is same. Case of F3 and F4, here the range is ABC and codomain is also ABC. So this is the important characteristic of onto function, that codomain is equals to a range. So important conclusion that f that x mapped on y is onto if the range of f is equals to codomain y. Now a function is said to be bijective if it is 1 1 and onto, that is both injective and surjective. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.